Now, on the computers in existence in 1988 in Mr. O's class at City College, we had a square wave as a computer clock. Now, that square wave will always be running, and things happen at certain positions on the square wave, and at a certain time from the beginning of one wavelength in that square wave step, whether 1.6 gigahertz or 10 gigahertz. Now, the way that clock have things in the IC move around, you will have a photonic clock doing the same thing. But you will not have binary bits. You will have decimal bits. And all the architecture will be for decimal representation without any reference to binary representation. You are not going to be backward compatible within the chip to binary. You can do that later using software. You make it a pure 100-bit decimal computer or a pure 1000-bit decimal computer on a chip. Because you're using decimal, say in the old computers, a register that is 4 bits. The highest number it can hold there is 2 to the 4, which is 16, right? Now, in a decimal system, you will not have 2 bits to 4 bits. You will start out with 10 bits. So the register default will be at least 10 bits for 10 different characters. In the binary, you can either have 0 or 1. In the decimal system, you can have 10 different characters. Now, that alone in the hardware will reduce complexity and number of iterations and things like that. Plus, you will have light doing it. It's faster. Light is faster. It's not only faster, the amount that you can use one word, 10-bit word for, is much more than can use a 2-bit word for. But the way it works will be more or less the same. What happened in a 2-bit system at this point in the clock will happen in the 10-bit system, in the decimal system, not bit, in the decimal system. Every part of a register will be a different value corresponding to decimal, not corresponding to binary. You can make a compiler outside of it to go to binary. Now the LEDs are not transistors, or you can make them transistors. You're going to use less. You're going to use less power too, because you're using light and not electricity, right? Your 100 nanometer system uses electricity and you're good with it. They have that system available already in photonics. You make your chip in such a way that you can imprint it on that chip using your 100 nanometer machines or your 5 nanometer machines or whatever. These are fundamentally different things. It's not 2 bits you're working with. You're working with 10 base 10 decimal, right? In 2-bit system, 8, you will use 3 bits for it. In decimal, you use 1 bit, 8, right?